Hey guys, let's get something straight about Bryan Kohberger's DNA. Because there seems to be a massive kerfuffle about Kohberger's DNA being found on the knife sheath. We know that Kohberger's DNA was found on the sheath because the PCA told us. The PCA, the probable cause affidavit, the arrest warrant, it only contains information sufficient for the judge to say, yes, there is probable cause for an arrest. And of course, because it's written before the arrest, because it's the probable cause for the arrest, then it's only going to contain the amount of discovery that was done up to the point of arrest. Up to the point of Bryan Kohberger's arrest, they did not have a buccal swab, so a cheek swab, from Bryan Kohberger, or any other swab, come to that, from Bryan Kohberger himself, because they didn't have their hands on him. Once they got him, they were able to do a buccal swab and get his DNA. That's why they were hunting around in the Kohberger's trash. And it's probably why Bryan was sorting his trash in the middle of the night with gloves on and putting it in his neighbour's bin. So, yeah, they probably were, when they went hunting in the trash, they were probably looking for samples of Kohberger's DNA. But instead, they got his dad's. So Bryan and his dad have had a paternity test. Because unless Kohberger Sr. had another son who left the knife sheath in 1122 King Road by the side of Maddie, unless Kohberger Sr. had another son, by process of elimination, the DNA on that knife sheath was Kohberger's. So, we knew that already, so I don't really know why there's a massive kerfuffle. But what I want to do in this video is to allay any fears, because I've seen people talk about the prosecution are hiding things from the defence. No, they're not. The defence are playing a good old trick of making it look like the prosecution are hiding things. The prosecution can only give them what they've got in discovery so far, so it doesn't matter how many times the defence asks for things. If they haven't got them yet, they haven't got them yet. The other trick they're playing, they're asking for things that the prosecution are under no obligation to give them. And one of them relates to this DNA issue. It's this document here, State's Motion for Protective Order, that has brought in all this kerfuffle about the DNA. So that was posted to the portal on the 16th. So here it is. All right, so we're going to read it. We're not going to read the whole thing, but what I'm doing in this video is making it clear that there's two different types of DNA testing. One that the state have to turn over, the other they do not under Idaho law. So SNP testing, and we'll get into what SNP testing is, and investigative genetic genealogy. Under Idaho law, the prosecutors are not required to hand over that information. So that's why they're appealing for this protective order, because the defence don't seem to understand Idaho law, or they're just trying it on. State of Idaho, by and through the Latah County Prosecuting Attorney, respectfully moves the court for a protective order pursuant to information relating to investigative genetic genealogy. This case arises from a quadruple homicide. Law enforcement found the DNA of a potential suspect at the crime scene, and the FBI submitted the DNA to one or more publicly available genetic genealogy services to determine potential relatives of the suspect. So this is being done a lot in cases, and cases that have just been cold for years and years and years are now getting solved because of this new, well, it's not new, it's not new, but it's law enforcement using genealogy services that we can all use. This is data that's out there that people have, like I have, people have submitted their DNA to one or more of these genetic testing services, and they've got their ancestry or their ethnicity or health concerns. The FBI then used common genealogical techniques to develop a family tree leading to the defendant. The state seeks to protect from disclosure the names and personal information of the hundreds of innocent relatives on the family tree, the names of the publicly available genetic genealogy services used, and certain other information described below. The disclosure of this information is not required by Rule 16 of the Idaho Criminal Rules. So Ann Taylor can jump up and down, she can jump off a desk, she can jump off a bridge, she can do whatever she wants. She can create holy hell throughout the state of Idaho. But the prosecution is not required under Rule 16 of the Idaho Criminal Rules to provide Ann Taylor, Bryan Kohberger, or anybody else with the results of the family tree, the names that were on that family tree, or the service that was used. Not required. Should be a protective disclosure for the good cause described below, blah, 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 including the state's privilege to protect the identity of informers as described in Idaho Rule of Evidence 509. Okay, so we know the deal here. The sheaf was face down and partially under Maddie's body and the comforter on the bed. So it looks like, you know, in the disarray in the murder, the sheaf has kind of got hidden. And Bryan, yes, I will say Bryan, because Bryan's DNA was right there. And some people are saying, right, this has made me laugh this week. Some people have said that if Bryan is the DoorDash driver, right, and the DoorDash was left in the house, and one of the cops investigating picked it up to tidy it away or to just move it. Bryan's DNA, because he was the DoorDash driver, was on the bag. Then the cop has transferred DNA from the bag on his or her gloves to the knife sheath. All right, that didn't happen. But anyway, that's what's been said. That's hilarious. Okay, the Idaho State Police Lab in Meriden, Idaho, located DNA on the Cairborne knife sheath. The ISP laboratory determined the DNA came from a single source, and that source was male. So importantly, that DNA came from a single source, so it wasn't a mixed sample, which can cause a problem, because then how do you isolate which individual you're actually talking about, who's the suspect here? So it's single source, that's good. Once law enforcement had single source DNA from the sheath, they conducted what is called a short tandem repeat STR analysis. This is one type of DNA testing. So this is the type of DNA testing that's done in, let's say, paternity testing, right? You're not sure a kid's yours, you know, so you send your DNA and the kid's DNA and you get a paternity result, right? So when they say this kid is 1 billion times more likely to be this person's than a random person, right? That's STR analysis. Involves looking at 20 regions within the human DNA and allows law enforcement to make a direct comparison between two STR DNA profiles. So I want to just be a little bit clearer on what this means. So this is from the National Institute of Justice. Think of DNA as a blueprint for a house and proteins as the steel, timber and bricks and mortar from which the house will be built. A brick that is mostly sand instead of clay will crumble, and mortar with the wrong ratio of cement to aggregate will fail. Likewise, a protein, because, right, DNA is coding for proteins that make up the body. So if there's a mutation in a particular section of DNA, it can create a problem for that protein, and that's what causes genetic diseases. A protein with the wrong sequence of amino acids won't function. Non-functional or missing proteins are the basis for many genetic diseases. Useful differences in DNA must be found in the remaining 0.1%, which is not known to code for anything specific, because this section of the DNA's precise sequence is not so important. It's very variable. So when mutations occur that create big problems for the body and create a genetic disease, often that person doesn't survive and doesn't even survive till birth. But sections of the genome don't code for any particular protein. So if it creates no problem for the body, it doesn't matter if that changes. It doesn't matter if that changes often, because it's not coding for anything. The DNA bases that don't code for proteins are regions with multiple copies of short repeating sequences, because they've just repeated and changed and whatever, which make up the DNA backbone. These sequences repeat a variable number of times in different individuals. Such regions are called variable number short tandem repeats, and they are the basis of STR analysis. A collection of these can give a nearly irrefutable evidence statistically of a person's identity because of the likelihood of two unrelated people having the same number of repeated sequences in these regions becomes increasingly small as more regions are analysed. Given a robust crime scene DNA sample with good data for all 13 SDRs, the likelihood of a person unrelated to the actual person who committed the crime having a perfect match is typically 1 in 1 billion. So sometimes you see numbers that go into like the trillion because they're that certain that two samples match based on the SDR profile. Okay, so law enforcement submitted the STR DNA profile of the sample found on the knife sheath to CODIS, but they didn't get any matches. Therefore, they wanted to go down the genetic genealogy route. However, genetic genealogy uses a different type of DNA analysis. Okay. So genetic genealogy allows individuals to trace their lineage or connect with unknown family members using DNA. Typically, it involves sending a DNA sample, such as a tube of saliva, to a genetic genealogy service like Ancestry or 23andMe. The genetic genealogy service then creates a single nucleotide polymorphism, or SNP, SNP, call them SNPs in genetics. So a SNP profile to use for genealogical purposes. A SNP profile is different than an SDR profile and is used more often for genealogical purposes. So what do we mean by a SNP? So a single nucleotide polymorphism refers to the presence of two or more variant forms of a specific DNA sequence that can occur among different individuals. So you get one strand of DNA from your mother, you get one strand of DNA from your father. So you get approximately 50% of your DNA from your mother and 50% from your father. The vast majority of the DNA that we share as human beings is identical, and our genetic differences come from the slight mutations that have occurred over time in our genetic makeup. And as I said before, in the junk DNA, which is not junk DNA, but the DNA that doesn't code for proteins, there's lots of variation. That's why that's useful in STR DNA testing. When you're looking at the DNA bases that code for proteins, those mutations matter. So any really serious mutations that create genetic disease that is it's not conducive to life, then you will die. Some genetic diseases are not life-threatening, like brown eyes and blue eyes, red hair and brown hair, dark skin and light skin, right? It doesn't matter for life, but those are all genetic mutations. And you can look at the different variants. This is how SNP analysis works. It's looking at the variants for certain strands of DNA. So it's a different type of testing. The genetic genealogy service then uses an algorithm to compare the user's SNP profile to SNP profiles submitted to the genetic genealogy service by other users to determine ancestry and potential relatives. The Genetic Genealogy Service shares with the user a list of potential relatives, and depending on the specific Genetic Genealogy Service, personally identifying information on those individuals, their name, email address, the amount of DNA the user shares with potential relatives. The user does not receive any genetic information pertaining to other database users. You just get told how related you are to a particular user. You don't have access to their genetic profile. Like on 23andMe, I can access my raw data. I can look at my SNP profile for all of my chromosomes, but another user that links to me can't, right? So Ann Taylor asking for all of this genetic genealogy information, she can't have it. Not available. Right, she's just being nosy. She can't have it. This same process, used frequently by members of the public, can also be used by law enforcement as part of their investigation, a technique referred to as IgG. Once a publicly available genetic genealogy service shows law enforcement potential relatives of the suspect, law enforcement applies traditional investigative genealogical methods to build a family tree in an effort to follow the tree to a suspect or close relative. The family tree can be used to narrow down a potential suspect based on factors such as age, gender, opportunity, known physical characteristics of the suspect, etc. So they knew from the DNA on the knife sheath that they're looking for a male. In this case, investigators used IgG to begin the process of developing a lead to the individual who left DNA on the knife sheath. The Idaho State Police utilised a private laboratory to develop a SNP profile from the DNA on the K-bar knife. The private laboratory started using genetic genealogy to develop a family tree, but after law enforcement decided the FBI would take over, the private lab ceased its efforts and sent the SNP profile to the FBI. So the FBI did this. Right, so if Ann Taylor doesn't trust the FBI, then that's Ann Taylor's problem. The FBI uploaded the SNP profile to one or more publicly available genetic genealogy services to identify possible family members of the suspect based on shared genetic data. The FBI could then view through the Genetic Genealogy Services portal information regarding to potential relatives of the suspect who left DNA on the sheath. Based on information the FBI could see in the Genetic Genealogy Service portal, the FBI went to work building family trees of the genetic relatives of the suspect. Okay, so they built a family tree using the same tools and methods used by me and members of the public who wish to learn more about their ancestors. For example, the FBI consulted social media, viewed vital records such as birth and death certificates, and viewed other information already contained in the user portal for the Genetic Genealogy Service, including the annoying, unverified information that users put on these sites. Alright, just be careful. So I'm sure they worked out which ones of those were unverified. The FBI consulted subscription-based databases available to law enforcement for information on individual people. The product of the genealogy conducted by the FBI was a family tree that contained the name, birth date and death date, if applicable, of hundreds of relatives, as well as their familial connections between each other and the suspect, Bryan Kohberger. So it led it right to him. Led them right to him. The FBI then sent to local law enforcement a tip to investigate the defendant. So they found him by his relatives doing DNA analysis. The IgG process pointed law enforcement towards the defendant, but it did not provide law enforcement with substantive evidence of guilt. The FBI did not, for example, conduct a direct comparison between the SNP profile from the K-bar knife and the defendant's SNP profile. It was just an investigative tool, that's all it is. It leads you to a suspect. It narrows down your field. That's all it does. It's not the slam dunk. The slam dunk is actually the STR DNA and obviously lots of other evidence combined. That type of direct comparison required the more traditional STR DNA analysis, which was conducted by the Idaho State Police. Prior to the FBI's IgG efforts, the ISP lab developed the traditional STR DNA profile from the DNA found on the sheath. So they've got Kohberger Sr.'s DNA. Now they've got Bryan's DNA through a buccal swab, a cheek swab. right? So they did STR DNA comparison was done between the STR profile found on the K-bar knife and the defendant's DNA. Right, get this. The comparison showed a statistical match. Specifically, the STR profile is at least 5.37 octillion times more likely to be seen if the defendant is the source of that DNA than if an unrelated individual randomly selected from the general public is the source. So let's have a look at what 5.37 octillion actually looks like as a number. It's just bringing up Bryan Kohberger. Right, let's look at what an octillion means. Octillion. An octillion is a number equal to 1 followed by 27 zeros. In the US. So it's 1 and 27 zeros more likely. Now remember, a million only has 6 zeros, right? This has 27 zeros. So I think that the buckle swab collected from Bryan Kohberger and the DNA on the knife sheath, I think it's Bryan. Unless a cop with gloves on touch the snap on the sheath. Why would they? Because why would they touch the snap on the sheath? Because the knife wasn't in it, so it's not like they were opening the sheath. No, the killer opened that sheath to take out the knife shortly before the murder. And who was that? Oh, it was Bryan. Oh, okay, it was Bryan. There you go. It was Bryan. Boom, slam dunk.